Very good, thank you. In all the years that I've had the privilege of being the CTO for IBM's Watson and AI initiative, I don't think that I've ever started a talk without this very simple statement, and that is that cognitive systems are about amplifying human cognition. Now, I make this point for a very simple reason, and that is that there still is a lot of hype out there about how AIs are going to replicate the human mind or replace humans, maybe even in the most sort of dystopian views, eliminate the need for human beings altogether. And clearly that's just not the case. And my rationale for believing that this will never be the case is simply a matter of economics. If you think about the entire history of the human species, and especially over the last 10,000 years of developing tools and using that to advance our societies, the one thing that we can say about almost every tool that's ever been created is that it has this one property, which is that it extends and amplifies our human strength. It enables us to do things that we couldn't do without that tool. And this is true for hammers and hydraulics and levers and wheels. I mean, you name it. Think about all of the tools that you use or that we have been using for a long time. And unless it has that property, it tends not to be something that we continue to make use of for very long. We tend to discard those things that don't have that capability or don't bring that kind of advantage to us. So the same thing is true here. AI is a tool. AI is a tool that allows us to do things that we couldn't do without it. It allows us to examine vast quantities of information to not only find in that the answers that are relevant to the problems we're trying to solve, not only just simply trying to identify the signals of information, the patterns of information that might suggest something meaningful to us, but even more specifically, to inspire us, to find things in the information, in the data, that causes us to think about the problems in a different way, to examine the alternatives, to consider the range of possibilities, and if nothing else, to help us think of the questions that we're not thinking to ask. And this, to me, is the most important and most significant value that we will get from AIs. Now, I also need to say something about the term AI, because the industry has largely conflated the term AI, artificial intelligence, with machine learning. You'll see lots of vendors out there, including ourselves sometimes, where we simply don't make a strong distinction between the two. But I do need to call out this one point, which is that while machine learning, and the subdiscipline of deep learning in particular, is highly useful in the world of AI, the practice of machine learning, the algorithms that we create that use machine learning as a technique for identifying patterns and making predictions about that data, is a practice that has as much applicability to the world of structured information, quantitative information, as it is for anything else. And so what we like to do is kind of distinguish that set of information that is of most obvious relevance to our human experience, our human language, our text, our natural language approaches for communicating, the things that we see, the things that we hear. You could arguably extend this also to other aspects of our human senses, and maybe even non-human sensory experiences as well, just because we as humans have limitations on the number of things that we are able to sense doesn't mean that those things don't exist. And if we could sense them, would have the same characteristics that the other things that we do sense have. That is, it's unstructured information, it's full of signal, there's lots of signal-to-noise ratio, and part of our unique human capability is to evaluate and assess, to judge, interpret, and apply the meaning of that information into the things that we care about. And so that's what AI is for more than anything else, is the focus of machine learning, deep learning, algorithmic approaches to data assessment on those things that have the highest relevance to our human experience. So let's go back for a moment and talk about this relationship between humans and machines. Because there are certain things that we can say with a fair amount of certainty that is sort of the unique properties of being a human being. Clearly, our ability to imagine, our ability to judge, to apply value to things, our ability to be inspired, to be creative, our ability to bring common sense. These are all properties that I think will continue to always be uniquely attributable to us as human beings. There are certain things that we're not very good at. We don't do vast computation in our head very well. We certainly don't do a very good job of assimilating large quantities of information or finding the patterns of meaning in that information. And this is where the machine, the tool of AI and machine learning, can benefit us. If we combine both our own human strengths with those of AI, that gives us a power to do things that we couldn't do on our own. So with that in mind, at IBM, we have focused on creating a platform for AI that is intended to facilitate the variety and range of uses where AI can benefit what we're trying to get done in our jobs, in our lives. And that platform has multiple points of entry to it. At the very bottom of this chart, you should see that we can deal with deploying AI technologies. We can enable the application of these technologies on virtually any platform that's relevant to you, and more importantly, to the platforms where your data exists. This is key, because the cost and difficulties of moving data around can be prohibitive in many cases, and without our ability to bring the work to the data, it would obviously limit the ability for us to get value from the AIs. Above that, you should see the machine learning services that we provide, the ability to apply elastic scaling to the task of training a model based on the data that you care about, and to be able to do that without you requiring you to go out and invest a tremendous amount of money in a one-off platform or set of hardware technologies for your particular use. If we can share those resources and we can get elastic utilization of those resources based on the demands that you and all your colleagues have around the processes of training models, then obviously we can make that more efficient for you and enable you to apply the problems of AI to, or the technology of AI to more problems. Above that are the tools for data scientists and domain experts to collaborate with each other on creating AIs and machine learning models for solving particular problems. And all of that's good if you're trying to create things on your own. Clearly, we want to enable people to innovate, to understand their own problem domains and be able to solve those problems with technologies that they can leverage from these tools and infrastructure. But there's also a whole class of things that we can say are fairly common and repeatable. And so for that, we've created a set of services with APIs, pre-trained, focusing on specific aspects of the human experience, the human expression, that accelerate the construction of applications, so that if what you need is something like a visual recognition service, you don't have to build that from scratch. You can use a service and simply embed that within your application. Above that are what we call higher reasoning skills. These are application services that aggregate a set of capabilities in the context of particular kinds of use cases or types of use cases. We'll spend a little bit more time on describing that in a minute, so I won't elaborate on that any further here. And then finally, we also, within IBM, but also with a lot of our partners, have created solutions for specific industry problems that even further accelerates your time to value if you can simply take one of these solutions and adapt it quickly to your problem domain. Now, the last thing I want to point out on this chart is this thing on the right. You'll see it labeled there as AI OpenScale. This is a recognition that in production environments, we now have a new resource called a model, called an AI algorithm. And that resource has to be managed. It has properties associated with it that are unique. And without the ability to manage the results of our work in the data science space, then obviously it's going to make it difficult for us to get the utility, the long-lasting utility out of that set of services that we might otherwise need. So let's go back and examine some of these, what I call basic reasoning skills, right? These foundational cognitive skills. We have a variety of these services. We have been developing and advancing and evolving these services around specific primitives in the human experience. Things like our ability to look at natural language, whether that's in the form of a document, in the form of a set of text, a set of tweets, a set of messages, emails, wherever that text is coming from, when there's a need to get in and understand the intention of the expressions in that text, there are services that we can apply and enable for you to go do that analysis. You don't have to build those from scratch. You can simply use the services. They're all pre-trained out of the box. Generally, they're trained on open domain linguistics, but they're easily adapted as well to very specific domains. So you can begin with something that is already developed for you, make use of it under general circumstances, and as you realize the need to specialize that, you can go back and retrain or adapt through transfer learning techniques to the domains of your interests as well. In addition to that, we have services that are focused on speech, human speech, vocalization, and recognizing and translating the spoken word into written word, speech to text translation. We also have text to speech, and we have the ability to translate between languages, between geopolitical languages or human languages. Next we have vision, the ability to recognize objects within an image or a video. In this particular case, we're focusing on identifying and classifying objects. There are other algorithms that we offer within IBM that are more focused on identifying specific scenarios, threat scenarios perhaps, for example. One particular product that we have called Intelligent Video Analytics is focused primarily on public safety scenarios. Scenarios where perhaps what you need to be able to do is identify a package that was left behind at a rock concert, recognizing that has potential significance as a threat or as a risk, and therefore deserves additional attention. Likewise, we can use these within, for example, ATM vestibules. If you could imagine the importance of being able to identify the potential for somebody coming into the vestibule and vandalizing or breaking into the ATM, or worse, attacking a bank customer who happens to also be using that ATM at the time, we can use IVA to identify and recognize that emerging threat, somebody walking through the door with perhaps a crowbar or some other tool that might be suspicious and represent a potential for that kind of risk, and use that then, of course, to alert authorities. Finally, I want to identify something that I think is often overlooked in our industry when we talk about AI and talk about these kinds of systems, and that is the need to be able to recognize human empathy. And by that I mean both human tone and emotion, but also personality traits. It turns out, through psycholinguistic analysis, we can identify with a fair amount of accuracy multiple aspects of a person's personality, a human personality, by the way that they write. Not just what they write, but how they write is a strong indicator of the personality. And of course, you can imagine this being applicable to many different situations. Likewise, we can detect somebody's emotional state or tone. That is, what emotional reaction are they trying to affect in other people through the way that they say things. The reason these are important is really goes back to the very first point that I make, which is if what we're trying to do is amplify and extend human cognition, and if what we're doing is operating in the realm of human experiences, then clearly the devices that we as humans use to communicate and convey our meaning, especially those meanings that are tied to our emotional state or the emotional effect that we're trying to create, is important to capture as well. It's important to understand what emotional state somebody was in at the point that they said something, because that it will affect the way that we interpret their intention and their meaning in what they said. So these are characteristics of foundational cognitive skills that are available as services that you can use and call through APIs to include in your applications and exploit for the purposes of whatever problem you're trying to solve. Now, as I said, we also have higher reasoning skills. And today, these largely fall into three main camps, one being around conversational systems, one being around a thing that we call discovery, and a third one that we just introduced called compare and comply. So let me talk about all three of these just in a little bit of detail. So first of all, conversational systems. Now, the industry tends to want to refer to these things as chatbots. And you probably are familiar with these. You may know Siri and Alexa and Google Home as chatbots that perhaps you use or that your family uses at home. And these are good. These are useful and powerful. The idea that I can get on Alexa and order new dog food with a single vocal command, it's kind of fun. It's kind of powerful and maybe a little bit productive. The problem I have with chatbots, as we experience them largely in the industry today, is that they tend to be single-turn interactions. Somebody saying something or asking a question and the system responding to that utterance. Alexa, order new dog food. Google, what's the tallest mountain in the world? Siri, what's the weather outside? These are single-turn interactions. And then while that's useful, the real issue is that for most people, when we go into solving a problem, a single turn is not going to get to the heart of the matter. It's not going to get to the heart of the problem. Right? If I say something like, what's my account balance? I may need to know what my account balance is, but that's probably not my problem. My problem is I'm trying to get ready to buy something, or I'm trying to figure out how to save up for my kids' education. There's something else going on behind that question, and a conversational system should have as its goal the objective of getting to your problem, getting to the point where you're able to reveal the true nature of what you care about, so that then the system can go on and assist in that way. And that's a big part of what we're trying to focus on in our conversational services, what we call Watson Assistant, to facilitate constructing applications whose goal is to get underneath the first question that people ask, to get to the heart of the real issue, to engage the user and use that to solve for their problems. Now today, the vast majority of these conversational systems are being used around things like customer care and customer support, employee productivity, and then of course, conversational commerce, which of course, as I said earlier, ordering dog food may be a simple example of that, but most commerce of any interest is more involved than simply making a simple utterance like that. So again, these are where conversational systems tend to be used today. That's not their limitation, however. It just happens to be the most popular ways in which that stuff is being used. I should also point out that, and I'm always reluctant to brag too much here, but I will in this case, we have spent a tremendous amount of time and energy on advancing our AI algorithms to the point where they can be trained faster with less data and greater adaptability, if I can even speak right, to other domains, right? And this is a particular projection of the rate at which we can train a conversational system with as few as 10 examples and get the system to recognize the intention behind those example utterances to the point where now when somebody says something even slightly differently to mean the same thing, it can recognize that and move on. So this is an example of the effort that we're putting into advancing our technologies underlying these services that we make available to you through APIs. Now let me switch to discovery. Discovery is probably the thing that people most often identify with the thing that we did with Watson for Jeopardy. If you're familiar with that game show effort that we published close to 7 years ago now, I think it's maybe even almost 8 years, that was about question answering against a large corpus of data. It was, if you're familiar with Jeopardy, it's a trivia game show, and the point is to be able to ask questions in the form of a clue and get answers in the form of a question. But for that to work, for us to be able to take Watson and compete against people like Brad Rudder and Ken Jennings, we had to be able to read the literature that was ingested into the corpus and do that real time. Well, that's what discovery does. It allows us to ingest a large body of literature, We do index it around knowledge that we are able to extract from that literature. So we do build knowledge graphs that you can use to traverse the knowledge that's contained within that literature. But we also allow you to then to examine that literature in the context of the questions that are being asked and use the context of that question as a means for finding the right information in that body of literature for the problem that you're trying to solve. Now, what's interesting to me about this isn't so much the fact that it can find the right information, but rather that when it does that, it comes back with a set of supporting evidence. What was its rationale for believing that this was the right piece of information to supply, given that inquiry? What are the other surrounding documents that reinforce its understanding of that being a correct answer? Because oftentimes when we look at supporting evidence in these situations, that will reveal more about what we don't know than simply getting the answer to the question that we do know. And we can expose people to other insights that are directly related to the answers that they're looking for. Oftentimes what it does is it triggers them to begin to think about the questions that they're not thinking to ask. And as you know, for many of the problems that we have to solve in today's society, it comes back down to, what am I not thinking of? What is that thing that somebody else is thinking of that I'm not thinking of that leaves me vulnerable to them exploiting their knowledge that I don't have? What is it that I could know that if I knew it, then whoever I'm competing with or whoever I'm dealing with, I can deal with them in a better way or a more productive way. So this is the advantage that I think we get from discovery. Now, it's very common for people to combine both conversational systems and discovery. To use conversational systems kind of as that front end for interacting with the user, finding out what their intention is, what their needs are, helping them get to the core problem they're trying to address, and using discovery as a way of trying to solve and discover the information that's needed to be able to help them with that problem. So it's not unusual that we'll see both of these being employed. And in fact, if you think about it in terms of the long tail, where there's certain kinds of questions that certain people, classes of people, tend to ask over and over again, versus the rest of the questions, which get asked more infrequently, but oftentimes have more sort of complexity to them, more sophistication to them, then this balance between conversational systems and discovery systems gives us the opportunity, at least, to get deeper down that long tail, to cover a larger distance of ground in the space over which we're trying to help people solve problems. Now, let me also talk about something new. This came out about a year ago, a service that we call Compare and Comply. And the purpose of Compare and Comply began with trying to focus on documents of governance. Think of that as being contracts or term sheets or invoices, things that in business we use to govern our business. And in here, what we've done is trained Watson to recognize certain aspects of a legal document or contract-like document. Things like, who are the parties that are represented within this document? What are the obligations that any of those parties have to each other? What are the terms associated with those obligations? And by classifying and focusing on this, not only does it give us the opportunity to very quickly scan a very large body of contracts or legal documents like that, and find out what are the obligations that we as an institution have in aggregate. But it can also be used for things like, if I am about to write a new contract, if I happen to have a boilerplate contract that I use typically for these situations, and now this new contract is being written, I can quickly determine where did that new contract deviate from the boilerplate, so that I can highlight what the exceptions and concerns or risks might be associated with that new contract and make a judgment based on that, as opposed to the risk of that information being lost, buried in the depths of this contract. So this has a lot of utility in these scenarios where we have these obligations that we have to address. And of course, the benefit there is it reduces our risk and exposure to those obligations, especially if there's some chance that those obligations are either forgotten, have been overlooked, or we simply weren't aware of them to begin with. Now, if there's anything I can say about IBM, it's that we have at the core of our DNA a focus on enterprise problems. It's in our name. International Business Machines is a reflection of the fact that we have spent the entirety of our 100-plus years concentrated on the problems of enterprise. And those problems tend to be fairly unique, not the least of which, of course, is that people are very sensitive about the information that they use to operate their business. They're very concerned about the scaling issues associated with managing their business. They're very concerned about the security and the protection of the data that they're trying to use or the processes they're trying to employ. And these are all aspects of what we focus on in our Watson delivery. And here's just a few examples of the kinds of things that we've been concentrating on. I've mentioned the idea that we can bring the work to the data as one example of that. Again, if we can't get the work to where you have your data, then what good is it? We have to be able to solve for that. But if we do, move the work to your data, or vice versa, if you choose to move the data to the work, if it's in the cloud, for example, we do so recognizing that you care about the protection of that data, and therefore, if you want to bring your own keys, you can do so. You can host the data in our cloud. It's under your key protection. Nobody else has access to that information. Nobody else has access to the keys that you're going to use to protect that data. Now, let me talk about something else here, which is, one of the things that we noticed is there's a lot of discussion about AI in the industry. A lot of people have asserted that they will get benefit from employing AI and machine learning to the problems that they need to solve. We've obviously had lots of discussions about the use cases where this is useful, but there's a lag. The uptake of using AI in solutions is very underwhelming, right? And the reason for this turns out to be a matter of confidence, a matter of experience and knowledge, a matter of having tried it and learned from that to know now what's possible, what works, and what doesn't work. And more specifically, the problem of trying to match this world of AI to our more traditional thoughts around how we conduct business. Information systems have been around arguably for the last 70 years, and we've been employing them for any number of business problems, business processes, in managing the things that we got to get done. We've all developed a certain utility from these information systems of the past. But for the most part, the way that we've employed these technologies, information technologies, to solving for business problems is by focusing on very structured kinds of problems. We have structured processes that enable us to employ computing to facilitate proceeding that process. AI begins with a very messy problem, which is the data that we as humans experience, which tends to be very unstructured, it's very ad hoc, it doesn't have a whole lot of organizational principle to it. Maybe you can find some principles around things like emails, which are sort of captured in the body of an exchange, or text messages, which are captured in the body of a message. But a lot of the other stuff that we have to deal with is not that well structured. And of course, the content itself is inherently ambiguous and full of unstructured. So as we begin to harness this sort of messy world of unstructured information in the context of processes that were previously designed to be quite structured and quite regular in order to get the utility that computing brings to the table, it creates a sort of gap, this gap between the world of the tradition and the world of the future modern AI-based computing. So we took that on, and we said we got to help people solve for that problem, and we introduced this thing called OpenScale. And its purpose is twofold. First of all, to help create abstractions that map the irregularities that you might normally find in an AI-based systems, or at least around the data that you're dealing with in that kind of a system, with the regularity that you would otherwise find in a procedural system around business processes. But probably the more important problem that we're trying to solve here is helping people begin to understand the current production state of their deployed machine learning models and AI models. So think about this. If you're in an environment and you've had a fair amount of success with your data scientists in creating, let's say, 10 or 100 or maybe even 1,000 machine learned models for doing inferencing on different problems, how do you know how well those models are performing? How well do you know how much resources are those models consuming? How much compute resources are those models consuming? How do you know how well they're performing in terms of their projected, anticipated accuracy? And just as important, how do you know how well they're doing in terms of being bias-free? Because as an emerging issue, one of the things that has become very apparent is the fact that the data that we train these systems with oftentimes have inherent biases in them. We've all heard the stories about ImageNet, a very popular database of images, labeled images, that people who want to do image recognition are using to train their image recognition models with. Well, ImageNet, as vast and as significant as it is, was largely a collection of pictures that were taken from North America, or at least the Northern Hemisphere. So guess what? There's a bias. There's a tendency for that data to have more images of, of Europeans and, white males. There's not very many pictures, or at least there's fewer pictures, of African or Indian or Southern Hemisphere populations. So it does a better job of recognizing white males than it does of black females, for example. That's a bias. That's a bias that was introduced because of the data that we're using to train these systems with. And so first of all, can you detect that your data has that kind of bias in it? Even if you are able to detect it, and even if you are able to correct for that, there still may be other sort of deeper, more institutional biases that are inherent in the data that you're dealing with. Example of this is where we see people in the financial services industry trying to identify the potential for a loan applicant to be submitting a fraudulent loan application. If you look at the data, it's very common for financial institutions to end up flagging people who are submitting for a loan application in the sort of 20 to 30-year-old range at a much higher rate of incidence than at other age ranges. And not because there's necessarily a higher degree of risk or a higher degree of potential for that age range to submit a fraudulent loan, but because there's less experience with people at that age range submitting loans, the data tends to be sensitive to the possibility that they're submitting a fraudulent loan. Well, that's part of what we are doing with AI OpenScale, is allowing you at runtime in your production environment to detect and identify where the outcomes of your models are producing these kind of biased results, flagging it, and even more importantly, giving you assistance in how to go correct for those biases so that we end up with a system that's more fair, or at least its fairness is fixed to the things that matter to your business in terms of differentiation. So if I could just sort of wrap this up quickly, it is clear that as we move forward, we're going to find more and more occasions where bringing AI into our world is something that needs to be adapted to our domains. It's something that has to be brought to where our data is. All the sort of, if you will, mechanical aspects of AI application are things that present themselves first and foremost as we try to introduce and exploit AIs. But the thing that I want to leave you with the most is understanding that unless we think about its use in the context of what people do and how to advantage them at doing what they do better, unless we focus on how we improve their experience, and I don't mean that sort of in the user interface sense of experience, I mean that in terms of the effect and benefits that they get from the information system, to advancing their needs, to advancing their potential to gain insight and inspiration and apply that to solving the problems that they have, then perhaps we're not thinking about the application of AI correctly. Instead, we need to be thinking about it in terms of how we use it to amplify human cognition. Thank you.